So, good afternoon. Thank you for having me. I'm Chris Hunt. I'm the Quality Engineering Manager at AccuMold. We're located just up the street in Ankeny, Iowa. This short talk will explain how AccuMold, a micro-injection molder, has used DevOps techniques to improve how we solve large systemic problems in a manufacturing setting. With DevOps originating in software development, the entire framework does not lend itself easily to manufacturing. However, through multiple Scrum events done over the past year and a half, we've learned what works well and what does not, so that we can use Scrum to reduce project timelines, increase value-added deliverables, and produce more sustainable solutions. So this talk will explain how AccuMold adopted Scrum to supplement their continuous improvement journey. So every organization or team is on some type of lean journey, whether they specify it as lean or not. We're all trying to do things efficiently. We're trying to minimize our costs so that we can maximize our profits. Unfortunately, there's not an easy button one can push to instantly achieve lean and reap all the benefits. Instead, it takes a lot of work and a lot of commitment from everyone in the organization. In my experience, one essential key to its success is having everyone across all levels share a desire to become better today than yesterday and better tomorrow than today. I wouldn't say AccuMold's achieved this, nor will I probably ever, but we certainly have improved our performance over the years. So today I'll share some valuable lessons we've learned along the way. So what do we do? AccuMold is a plastic injection molder that specializes in micromolding. Micromolding is a highly specialized manufacturing process that produces extremely small, high-precision thermoplastic parts and components with micron tolerances. We like to define a project as a micromold project in three ways. Micro in size, meaning the part itself is extremely small. Micro in features, meaning a small or relatively large part has micro-sized features that are critical to the fit, form, or function of a part. Or micro in tolerances, where the dimensional tolerances are just extremely tight. But often we find many of our projects encompass all three of these. As technology increases in functionality and decreases in size, the associated product design continues to shrink. So we help companies increase functionality in their current design package or enable them to do more in even smaller packages so that they can stay competitive in their relative markets. Here are some examples of, there we go, sorry about that. Here are some examples of some of the parts that we do, because I can't really point. So we produce parts across three major injection molding platforms. The one we're known for is Micromold, and that's what you see along the bottom here. We also do small mold, which utilizes larger equipment to make slightly larger parts, and that's what you see here. And then we do lead frame, where we inject plastic over a metal insert, which you see across here. And you'll notice the penny here as a reference to the size of parts and part features we work with every day. One of our smallest parts, for quite some time, this was AccuMold's smallest commercial part, is this alignment spacer. It measures 800 by 380 by 360 microns. It takes about 144,000 of these to weigh 1 ounce. Honestly, we had a harder time figuring out how we're going to handle the part than we did figuring out how to mold it in the first place. So, how big is a micron? This visual does a nice job of showing the scale. So the average strand of human hair is about 60 microns across in diameter. So you can see the red dot there is a micron to give you an idea of what we're working with. So needless to say, everyone at AccuMold has to work under a microscope, and we all have to be extremely careful if we're going to sneeze while inspecting parts. AccuMold started in a small garage about 30 years ago, where two gentlemen saw a need for small plastic parts, but realized there's no technology available that could produce such. So they quit their jobs, and they invented what we believe to be the first ever micromolding injection molding machine in the world. Over the years, we've grown to Over 350 employees. We now run production 24 hours a day, 7 days a week, and we're making parts on about 155 injection molding machines across our facility. The parts we produce supply a variety of industries such as microelectronics, micro-optics, automotive electronics, but the majority of our parts end up in medical devices. We have customers all over the world. They come to us to help design and produce their next generation products. 60% of the parts we make are shipped outside of the US, and all from our single location in Ankeny, Iowa. So we're an injection molder. What is injection molding? This slide gives you an idea of the process, and this process begins when we start with small thermoplastic resin pellets are fed into a heated barrel via this hopper. Within that heated barrel, there's a screw that spins. So the heated barrel melts the plastic, the spinning screw pushes that plastic into the mold cavity. Upon injection, both sides of the mold are clamped shut to counter that injection force so that it doesn't blow open. Once it's in there, the plastic solidifies. We may have to use a cooling agent. We'll run water maybe through both sides of the molds to make sure that that plastic solidifies. But once it solidifies, the mold opens, ejection pins push the part out, where it can be harvested by most likely a robot, some kind of automation system, or dropped into a special container depending on the customer requirements. This shows you an example of a single mold cavity, a single cavity mold, meaning we only make one part per cycle. We also make multi-cavitation tools where we can shoot up to 32 parts per cycle. It just depends on the customer's preference and what they need for their project. Most injection molders out there produce parts ranging in size from small children's toys to eyeglass frames to lawn chairs or car bumpers. These parts are created on much larger molds that might require an overhead crane to pick up the mold, put it in the press. So in order to make very small parts in the micro level, AccuMold had to develop an innovative injection molding technology, and we did such with molds that can fit in the palm of your hand. So in order to protect this IP, we didn't actually patent the technology. Instead, we took the trade secret approach. So much like how Coca-Cola has been able to keep secret their soda recipe for over 100 years, or how only a select few know the exact combination of the 11 herbs and spices that make KFC so addictive, we too have kept our technology under tight wraps. And this approach has enabled us to be the world leader in micromolding. Another key pillar of our success is our adoption of lean. This is no longer a novel step in the manufacturing world, but it has proven valuable for us and enabled us to continuously improve as our business scales up. Some of the lean tools that we use, design for X, so design for manufacturability, design for final assembly, or design for some customer-driven requirement. Value stream mapping is a tool we use to map all activities, both non-value added and value added, from what it takes to have the raw material to the part in the customer's hand. We've used process flowcharts quite frequently. These just show the steps of a process in sequential order. They'll include materials, people involved, decisions that need to be made, time spent at each task, and perhaps some measurements that need to be taken along the way. A Kanban, or a pull system, is a just-in-time system that uses flags or lights to trigger the flow of material or information through a process. This is much more beneficial than a push system. With a push system, you might build up a bunch of widgets and have all of your inventory just holding up money there, holding up potential uses elsewhere. So a pull system, of course, is always ideal. And then Kaizen, everyone's heard of Kaizen, continuous improvement. So for me, as a quality engineer, from that perspective, my drive is to eliminate waste across all of our processes so that I can easily expose risk. Only then can I identify the risk, quantify the risk, and then correct the risk. And this minimizes cost of poor quality downstream. And again, this perspective, these tools can all be used in any process, even those outside of manufacturing. So about a year ago, as part of our continuous improvement journey, we decided to see if Scrum could help us solve those larger systemic problems that have plagued our manufacturing process. Before this, we took the traditional waterfall or over-the-wall approach to project management and saw our fair share of inefficiencies along the way. We found that problems would take much longer than we initially intended to solve. Some of our sustainable corrective actions fell by the wayside after a few months, and sometimes we simply misdiagnosed root cause of a problem because we didn't have the right individuals on the project team. So to be honest, I was not optimistic about trying Scrum after seeing it fail at a previous employer, a medical device manufacturer. In that experience, Scrum was touted as the end-all, be-all solution to all of our project management problems. Unfortunately, we didn't have buy-in up and down the organization. So we had a few failed starts. Quickly, it attained that flavor of the week status, and at that point, there's no way it could have been successful in the organization. So when I was asked to take product owner training at AccuMold, I thought this could be a great opportunity to use what I had learned, make sure that I sold Scrum to the organization without the downsides that I saw at the previous company. And so no one likes change, so you had to be creative on how you'd get, how to sell Scrum internally so that it had its fair shot across the organization. So far, we have had success with Scrum. We've solved a number of problems across our organizations and different business units, each enabling our Scrum team to tweak how we work within the Scrum framework to better benefit our needs. So we've used it to review, rewrite, and release our latest employee handbook, to design the training plan for new hires' first 90 days. We developed a new process to ensure molds are production ready. We optimized our current process for building new and modifying existing molds. And we defined and streamlined our quoting process and then improved our engineering change order process, or ECO process. The most noteworthy Scrum event at AccuMold enabled us to quickly design and implement an entirely new process within our manufacturing system. The production-ready equipment process, also known as PREP. I will note we were pretty pumped that the name turned out to be a nice-sounding acronym at the end of it, so that was just a nice win to kick off the project, but it is now one of probably 1,000 acronyms within AccuMold. Probably not unlike some of your groups, but so AccuMold designs and manufactures injection mold assemblies, and these assemblies enable us to make plastic parts. These assemblies can vary in complexity due to a number of design considerations, whether it be the resin used, the temperature at which that mold must run, the packaging requirements, or the geometric intricacies of the part itself. Typically, the more complex a part, the more complex the mold assembly required to produce it. So that being said, we had a lot of our molds we found that a lot of our molds were unable to run consistently without having failures, and so they were incurring a lot of maintenance costs. The majority of their time was being spent in the tool room accruing costs instead of being in the press making parts to bring in revenue. So this was a big problem. Obviously, our first step was to capture current state. So this image shows our process map, or excuse me, our flow chart of all of the steps necessary to take from that mold design to creating the mold to bringing that mold into production to where you can finally produce parts. And more importantly, can start making money. So per the Scrum framework, we gathered a cross-functional dev team. We had project engineering, process engineering, the tool room, production scheduling were all represented. The product owner was from quality, and the Scrum Master was our VP of Human Resources, so we had insight from all over the organization. We utilized week-long sprints to identify, prioritize, assign, and complete our work. Each sprint included sprint planning, daily scrums, a sprint review, and retrospective, and our work was identified as user stories, which populated our product backlog. At the end of each sprint, we reviewed with our stakeholders to share our progress and to confirm our working objective was still aligned with theirs. So with this being our first large Scrum event, we found many opportunities for improvement for how we should approach Scrum events in the future. For starters, a week-long sprint was pretty tight for the amount of work needed to be completed. From the amount of time, or from the time we assigned the work to where we were sharing completed work to the stakeholders was just too short. So to remedy this, we tried to assign work to the dev team to be completed outside of Scrum meetings, and this failed as well. Other priorities seemed to take precedence over Scrum work, and so nothing got done. Lastly, we recognize that we need to have a better understanding of the project scope before we start an event. So considering this particular process we were working on and all of the significant business aspects it was related to, we probably bit off more than we could chew for this Scrum event. But on the plus side, we were able to accomplish quite a bit due to the dev team's varied expertise. With the completion of each sprint, we could confidently estimate the overall completion date to our stakeholders, which was very important for them. That was a key requirement for them, not only from a time perspective, but it enabled us to estimate the labor cost we were investing in the project. When it was all said and done, though, everyone involved was quite impressed with the amount of value-added deliverables provided by the dev team, considering this was just a 5-week-long Scrum. So recently, we completed a Scrum event to improve our coding process. Before kicking this off, we reviewed lessons learned from past Scrum events so that we could make sure we tailored this event such that we wouldn't repeat some of those big mistakes or big headaches that we had experienced in the past. So previous to this event, our coding process was not completely defined. There were a number of actions we were completing in execution that weren't documented, and there were a number that were documented that we simply weren't pursuing any longer. But the biggest problem was that the current state was that oftentimes we wouldn't be able to successfully kick off a project because we had unclear requirements or missing information. So that was one major goal of this, was to make sure we didn't complete our quoting process until we had all the necessary information to ensure a successful project kickoff once the PO came in. So based on our previous success, we gathered a dev team comprised of a cross-functional team. We had representatives from project engineering, quoting, customer service, production planning, production, and quality. That's pretty much all the major groups in our operations team. And this event was limited to a smaller scope than what we tried to tackle in the prep project. So we limited it to only one 3-day long sprint. We still held our sprint planning session, our sprint reviews, our sprint retrospectives, and we had daily scrums at each day. And this enabled us to identify work to be done, size and prioritize accordingly, and then assign the work to the appropriate individuals on the dev team. So this approach proved successful as we were able to provide many value-added solutions in a very short timeline. We were able to standardize and document our process of receiving and entering customer requirements or documents in our ERP system. And we updated the process by which we design and manufacture molds with an alternate path for when we received a delayed PO. But most importantly, we added stopgaps to our process to ensure we were asking the appropriate questions so that we could gather that information that would ensure we had a successful kickoff once we were ready to actually start the project. Overall, the AccuMold leadership team was very impressed with not only the solutions provided by the dev team, but more importantly, our ability to improve how we use the Scrum framework to align our actions with the benefits of the organization. So we are obviously not the only manufacturers using Scrum. There are many examples out there. However, I'll end with an example which is by far my favorite. Both of these fighter jet programs were started around the same time. However, their outcomes were drastically different due to the use of DevOps techniques in one scenario as opposed to traditional in the other. So on the left, you see the F-35 Joint Strike Fighter jet. The design, manufacture, and assembly of this jet were driven by a traditional waterfall project management approach. This project went $143 billion over budget. That's not just their budget, but over their allotted budget, and drove their selling price to over $330 million. On the right, Saab used Scrum to design, manufacture, and assemble their Gripen jet. Using the Scrum framework enabled them to release a new and improved iteration every 6 months. Their overall program cost was about 20% of their competitors at only $15 billion. This enabled them to provide a much higher quality product at a significantly lower price tag. Over the past few years, the Gripen has won multiple contracts all over the world, while their major competitor is still fighting a computer glitch that has halted their market release until sometime this year. And this is all because the use of Scrum enabled Saab to fail fast, so they could learn from their failures sooner than later and correct the design. This agile approach enabled the project team to quickly identify design flaws earlier in the design phase so that they could release a more robust product with a sooner time to market. So as mentioned before, every organization or team can benefit from streamlining their operations and minimizing the amount of time and money they spend on any process input. Whether you're manufacturing microcomponents or writing code, the benefit of operating lean is very much valuable. There are a plethora of methodologies and tools out there to utilize. They may be categorized as lean manufacturing, or they may fall under the agile umbrella, such as Scrum. But whatever they may be, I encourage you to try them and see how they can add value to your operations. Adopting a lean culture will enable you to remain agile, be immune to market volatility, and ensure that you stay on your continuous improvement journey to become better today than yesterday and better tomorrow than today. Thank you very much. If anybody has any questions, I can entertain those. Yes, sir. Sure. So we have a number of technologies, CNCs. There's a device called a Cerix machine that's commercially available. We have 9 of those, and we're the largest collection of them in the world. And it's kind of a level below micro CNC. So yeah, you can imagine, in these mold assemblies are many pieces of steel coming together to create these different shapes and geometric intricacies. And so, yeah, we've got, but that's part of our IP as well, is how we can actually design and manufacture these. But yeah. But we do. There are some micromold injection machines available in the market, but they really can't be consistent as ours. So that's kind of what gives us our edge. Well, thanks again.